5.3 involves normal distributions and finding values. Um, so in this first example, we want to find the z-score given the cumulative area or the percentile. Now, one way of doing it is I got the 0.0290. That's the area in the curve. I could use my table. So if I find that 0.0290 in my table, takes a little bit, 0.0244, 0.0290. Let me see, pause my video for a second. Look how hard that is and see if I can find that. So looking around there, I think I finally found it. Looks like this negative 1.89 would be the closest thing to 0.0290. So we would have to use that estimate there because it looks like the closest one is that. Now, instead of using the table, we do have our technology that does things backwards. So under distribution, if we go second distribution, number 3 does the inverse normal. So what that means, instead of looking for a z-score, it'll actually find the z-score. So number 3, if I type in 0.0290, don't need to change the mean or the standard deviation. And the tail, I think we want to go left there. I'm not really sure what that means. My other calc didn't have that. Let's see what happens here. So that gave me that negative 1.8. That actually would be negative 1.90. Let's try with the center. Let's see what that does that way. Inverse normal. Because we're talking about normal distribution. So maybe I need to be doing center for normal, not skewed. Let's see if that makes a difference. That doesn't give me anything that I'm familiar with. So it looks like the left one did better because, like, to me, the area of the curve would be cumulative area. We kind of go that way. So that's what I'm kind of seeing. We can double check the right one as well, but yours may not do that. If I change it to the right. So it looks like it's kind of doing those different things. I don't know, it didn't give me those options. So that gave me 1.89. That also gave me the same thing. So it looked like if yours does that, left will be just left is what we had as well, because again, we're doing usually cumulative area is from the left. So I would say left is the best way to do that. So that would be negative 1.89. Spend my pen to work here. Or I guess negative 1.90 would be closer based on this. So that's where technology and tables vary a little bit. So you just have to experiment with that as well. The next one I have is the 0.7995. So if I use, again, if I clear my calculator out and do second distribution, if I do number 3 inverse normal, if I change that to 0.7995, mainly the mean is 0, standard deviation is 1. Again, let's say left again, as I think that means cumulative area there. Like some other calculator didn't do that. And that gives me this 0.8398 as my, so if I ran that to 2 decimal places, that looks like that's going to be like 0.84. Okay. So 0.84. Let's see what the table does there in that sense. So if I look at that 0.799, see if it shows the same thing. So 0.84 would be here, 0.7995. So now looks like that left one is making the difference there. That gives me the same thing that's in my tables. Okay. All righty. Learn something new. My other calculator didn't do that. So question, we have C here. This is a percentile question. So remember, percentile is like cumulative area as well. So the 15 means 15%. 15% percentile. But remember, when we do area under the curve, that's got to be moved 2 places to the left. We have to be using 0.15. So the cumulative area is basically that 0.15. So we can essentially do the same thing we just did, except we just had to change that 15 into a decimal, because percentiles means you did you're 15% better than the rest of the people, which is not exactly all that great. So let me see here. Got distracted. So number 3, we do 0.15. And again, everything else we keep the same. And that's going to give us this z-score of negative. Let's see here. Again, we usually round to 2 places on z-scores. Negative 1.04 looks like it, because that's 3 would be my second place, and that 6 would say round up to a 4. So we have that. And then this percentile of 88%, we want to find the z-score of that. So again, percentile means 88% of cumulative area, if you will, or I've done 88% better than the rest of the people, which is much better. But as far as our table goes, our inverse normal, trying to find the actual z-score that goes with that, we can kind of do the 0.88. So if we hit the second distribution, number 3, inverse normal, we change it to 0.888 or 0.88, and then move that on down through there. Go one more, and then that looks good. That gives me then this 1.17 as my z-score. So 1.17, because again, that 4 would keep the 7 as is. Okay. So the next example we have is find the z-scores shown by the graph. So again, this looks, again, the cumulative area is going to our left. So let's see what we got going on this one. So again, this looks like all I got to do is just use my inverse normal again and just do the 0.3520. I don't want it to look any different. So that's that. But we type in 0.3520. Don't change anything else. Left is good. Base. And that's going to give me then my z-score would be then this negative point. And that makes sense because we are left at 0 there. So my z-score there would be negative 0.3. Again, 4 decimal places would be that where that second 9 is, and that 2 would say keep that second 9. So 0.3799 would be our z-score. Okay. Now here, if we kind of do it the way we've been doing it, we're going to be doing the, so they gave us this area, but really what I want is this other area. So if I go 1 minus this 0.7190, that'll give me this left side here. So if we go 1 minus 0.7190, that gives us that number there, this 0.281. So the area of the curve there is 0.281 over here. So let's see what z-score is associated with that 0.281. So second distribution, number 3, we have to type in 0.281. And then we drop down and we get then more. I get this one more. So again, that should be negative. That looks good. So we have this negative 0.57. So we have a 9.8, but there's a 7 after that 8. So that means that 8's got to move up to a 9. So 0.5799. Now again, since I was doing z-scores, I should be rounding to the 10th place. So let's try that again. So the z-score here should really be, we should be using like negative 0.38 for the z-score. And here I should actually be using the z-score should actually be to the two places past decimal. So it'd be probably negative 0.58 as well. Okay. So I wonder if we did this to the right. I don't know if yours does it or not, but mine does. Let's see if this does. What happens if I do the right? So if I do the inverse normal here, keep the 0.7190, notice how the area is to the right. Let's see if this actually gives me that value, since the tail went to the right. Yeah, it does actually do that. So if the tail goes to the right, I have this 0.58, negative 0.58. Yeah. So this next example, so remember the area of the curve is 1. So halfway point would be 0.5. So the halfway point would be 5. So all this over on the left side would represent 0.5, but also we're missing part of the 0.5. So if I go 0.5 minus this 0.475, that'll give me my left side that I'm missing. So what is 0.5 minus 0.475? That's going to be 0.025. So this little z-score here would be like 0.025. So then if we do the inverse norm of that, number 3, it's going to be 0.025. And again, I'm going back to left. That's what I'm more familiar with, left of the curve. It's going to give me negative 1 point. And that looks about right. So the z-score is pretty close out there to where that negative 2 is. So z is negative 1.96. That's the first one. Now to get the second one, you actually have to use, if I'm doing left side, I got to be doing the 0.5 is the area to the left and the area to the right. So to find this spot right here, I got to do 0.5 plus 0.475. And that's going to be 0.9475 in it. I'm sorry, 0.975. Let me double check myself there. 0.5 plus 0.475. That should be 0.975. Yeah. Don't know what I was doing there. So we all get kind of dependent on this calculator, and we start to slow down on this little math here. So that's the area of the curve, would be this 0.975. So if I want to find the z-score associated with that, I can do that inverse norm. Number 3, it's going to be 0.975. And then if I go down here, and I'm keeping it left the way I'm doing it, and that would be 1.96 as well. And that makes sense because it's kind of symmetric. So negative 1.96 and 1.96 seems to be good because of symmetry. They're equal distance from 0. So really, I have to find one they kind of mirror across there. It's kind of what we're seeing. I wonder if we did center, what that would give us. If I use, because this kind of goes from the center. If I do 0.475 center, let's see what that does. Standard distribution normal, I should say, inverse normal. So if I use actually the 0.475 is what they gave us. If I do that from the center, if yours does that, I wonder if that gives me that answer. No, it doesn't give me what I was looking for. So I don't know what that center does. It's not doing what I wanted to do. Okay. So it looks like it tries to give me 2 z-scores, but they don't look right. All righty. Still would have to play with that. So the last one, again, if we find this first z-score, that's what we want, is the tails to the left, if you will. So if we use our inverse normal there, we can just go straight into that to find that z-score. So go back to distribution number 3, and we want to type in that 0.05. That number looks familiar too, that 0.05%. So, and again, we want that left tail. So, and that's going to give me negative 1.64. So if this z-score is negative 1.64, because of symmetry, this other one should be also 1.64. It's just going to the right of 0, so it should be positive. But if I was finding the area of it, again, I would have to go like 1 minus the 0.05. So 1 minus the 0.05, in other words, 95% of the area is covered. That should give me the 1.64 if I did it that way. Because remember, I'm going from the left, not to the right. So second distribution, number 3, if I change it to a 0.95, that should give us a 1.64. And it does. But we can also use symmetry to do those as well. So once we find one, we can identify the other one because of symmetry. All right, so what else we got over here? So find the z-score that is 11.9% of the distribution of the area to its left. So again, this sounds kind of like we just did without the graphic. So 11.9%. Notice that the area under our curve is actually got to be a decimal. So the 11.9%, we have to move the decimal 2 places to the left to use our functions. So it's going to be, the percent's going to be changed back into a decimal form of 0.119. So again, that's going to be the area of the curve. So that 0.119, because like I said, this is 0 here. Here's 1. I'm sorry, here's 2. This is the area of the curve though. So the area of the curve is this 0.119. We're just trying to find the z-score that goes with that. So let's see, second distribution, number 3. So again, it said left of the 11.9%. So we are going to be this way, 11.9%. So it's going to be somewhere in that area. So we put the 0.119. And again, we always like to kind of go left there. Makes better sense. And we do get this z-score negative 1.18. So notice how we are between -1 and -2. So my estimation wasn't too bad there. So the z-score for that would be negative 1.18. Now, if I have this 20.9% distribution, notice how it says this time it wants the area to the right. So the 20.9% of the distribution area is to its right. So to me, what would this be saying? I'm going to pause a second and make sure I've got this on the same page here. Yeah, so I think it's right here. So on this one here, the we'll get rid of this here. The 0.29, the 20.9% is going from the right side. So what we're having is something like this over here. 20.9% of the area is filled. Or in other words, this is like 0.209 of the area. So notice that we really want the complement of that. We want 1 minus this 0.209 as our area, because that's how our z-score works, is from the left tail, not the right tail. So if we go 1 minus this 0.209, we get this 0.791. So now if I want to do my calculator, we can do inverse distribution number 3, inverse normal. We want to put a 0.791 in. And based on where our drawing is, we should have a positive z-score. One more. And we do have like a 0.81. Yeah. So our z-score would be 0.81. So yeah, that would be kind of where we are with that. All right, so that takes care of a couple of those examples. So next thing we have is heights of women. We have kind of an application here. In a survey in the United States, ages 20 to 29, the mean height was 64.2 inches with a standard deviation of 2.9. what height represents the 95th percentile. So again, we can use our calculator for this. Again, the 95th percentile means, again, a cumulative. So if I just draw my little curve here on this, since this is kind of where our curve would be, you know, that 95% would be kind of like all this here to the left. Don't you just love my beautiful curve? So we just have this really small part over here to the right. So see if what we can do with our inverse thing here to find the, so we're looking for the height, not the z-score here. So time out. They changed the question outs, didn't they? So yeah, let's see what this is all about here. So if I get my eraser going on here. So what we pick up on is, in this question here, they're actually looking for our x value. So our z-score would have been equal to like x minus x bar over the standard deviation. But if I modify this equation, I can rewrite this as, again, if I cross multiply, that's going to be x minus x bar equals theta sigma times z. If I had x bar on both sides, x equals then sigma z minus plus x bar. So to find this problem right here, we got a couple things going on here. So see if we can piece this all together. So we have this formula we can use to find the missing sample piece of data, since we do know the standard deviation, which is 2.9, and the mean height is 64.2. But what we would not know is the z-score. Well, we just did something with z-scores. So remember, to find the z-scores, we just did something with percentiles. So if I use my calculator, I could probably go 0.95 into this the inverse normal distribution, and it should give us then this 1.644. Then all I got to do is multiply the z-score times the standard deviation, which is 2.9. So I can say like 1.64 there, or I'm gonna just leave it in there, just keep it accurate, so I don't have to round it here, just keep on going. So I can multiply that by 2.9, which is my standard deviation. Then if I add the mean, which is 64.2, that should give me the height of the person. So 68.97. And since we're rounding to the 10th place, you know, we probably say this height would be 69.7, right? That make that go all the way up to 69. So 69.0 inches. Now, to do it on the calculator, what you can do is once you find the z-score, actually, don't think you have to find the z-score. I think you can just use the 0.95. So if I hit second distribution, the shortcut is, again, do inverse normal. The 0.95 is going to stay there, but what we do here is, instead of the mean being 0, we actually use the mean that they give us, which is the 64.2. And this will actually find our x value, I believe, if I change the standard deviation to 2.9. And again, we're going from the left, hit enter. And notice how it does give me the answer, 68.97, without actually having to find the z-score. So we can kind of bypass the formula we just used and just go straight in to the inverse normal. And, you know, 43rd percentile means that from the left, we're 43% better, because again, percentile is cumulative. So I can go second distribution, third one is inverse normal. I can change that to 0.45. My mean this time is going to be the 64.2. The standard deviation is going to be the 2.9. We want that tail to the left. And I get 63.8. Yeah, 63.8 would be that answer. So 63.8 inches. So again, the mean is 64.2. Remember, the 50th percentile would be halfway. So 43rd percentile is kind of close to halfway. So we should be kind of close to 64.2 if we think in those terms. So again, we're talking about normal distribution and all that. So it kind of goes into play that way. So if the height is the first quartile, quarter kind of means 25%. So pick up on that. Quartile means 25%. Percentile means per 100. Quartile means per 25 or 25% of 100, if you will. So again, that's going to be a left concept. So we're going to still be able to use the cumulative, but we're going to use number 3 and go backwards. So we use a 0.25 for quartile. The standard deviation and the mean, 64.2, the mean stays the same. The 2.9 stays the same. So if we go that way, we should get 62.2 inches as an answer. So that would be those answers there. So we actually could still use inverse normal. In here, though, we have to actually put the mean and the standard deviation in. Or again, we could actually use this formula to find the z-score and then apply the formula to it. So energy consumption, let's see what we got here with this one. So the per capita energy consumption level in kilowatts in Venezuela for a recent year can be approximated by a normal distribution. So what consumption level represents 5 percentile? So based on our graph, it's a normal distributed, and also how they give us our mean and standard deviation down here. So this looks very similar to what we just did. So I can go my distribution, and then to go backwards, since we're looking for the actual consumption, we're looking for a number. We use number 3, and 5%, 5th percentile means 5%, or that's going to be 0.05. Got to move the decimal 2 places to the left. The mean this time is going to be that 2277 kilowatt hours. So 2277, 2277. My standard deviation, oops, I got too many 7s there, don't I? Let's take one off there. There we go, it looks good. Standard deviation would be 584.2 kilowatt hours. That looks right. Again, we like to have that left one on mine. You shouldn't have that, I don't think. Who knows? So we end up with this then 13, 16. And let's just, since these answers here are rounded to looks like the numbers down here are all to the integers, we'll round this to an integer as well, to the nearest whole number. So this is going to be 13, 16 kilowatt hours. 17th percentile, again, that's 17th percent. So if we use the inverse normal here, number 3, again, this changes to the 17th percent, 0.17, because the percentile is percent. The mean and the standard deviation did not change. And we get then this 1719, actually 1720, based on rounding, 1720 kilowatt hours. And then what's the consumption level represents the 3rd quartile? Well, that's 325s. That's actually 75%. 3rd quartile, that's 325s. So we're going to use 0.75 in here instead. Because again, we want to go from the left, not from the right. So you could have used 25% from the right, but then we could not use this without getting a little too tricky. All right, talking too much again. Number 3. So we're changing that to 75% because quartiles, that stays the same, that stays the same. And again, we're doing from the left because left is cumulative. So we end up within this, let's see here, 2,671 if I round to the nearest integer kilowatt hours. All righty. So there's some examples of, again, taking advantage of technology to do some of your homework and kind of working backwards now to find Z-scores and also, um, actual sample data pieces.